never took a how to teach class. My mom and dad are both elementary educators, but you kind of pick up stuff along the way. So the one thing that I've kind of held on to that my major professor taught me was little bits of the apple. Not try to compress everything all at once or cram everything all at once, because then you lose sight of learning. And so I try to introduce you to certain things at one point, and then we're going to develop those things, and then hopefully by the end we'll have mastered those things, okay? So some of these concepts that you're going to see up on here, you're like, well, didn't we kind of talk about that before? And it's like, absolutely, when I introduced them to you. But now we're going to have to develop them, because if you thought we had some illusion stuff on the first test, it gets a little crazy. And hopefully you guys, now some of you that took that test, some of you that took that test, believe me when I say that your brain like is playing tricks on you. You know, man, how does, it has to not be moving, right? Okay. So, analyze appendicular joint motion. What I want you to consider is that we have things that move that are in the midline. And right and left are going to mean a little different things when we have one of something versus when we have two of something. So what I mean by that is when we have movements that are kind of in the middle, it's going to be to the right, to the left. Like do a cartwheel to your right, cartwheel to your left, spin to your right, spin to your left. Appendicular joint motion is literally the right or the left. Lots of rights and lefts. Okay? So when I say analyze movement joint by joint, it's not just ankle, knee, hip. It could be right elbow, then I'm going to analyze the left elbow, because these do not have to do the same thing. It's analyze the left hip and then the right hip, because these two hips do not have to do the same movements. So it's not just ankles, knees, hips, shoulders, elbows. It's right ankle, right hip, left hip. We analyze movement joint by joint. And in appendicular motion, we have to be aware that we have two, okay? Now, we have a right and a left side, but then we have a right arm and a left arm, but yet we still have sides on those rights and the lefts. So this is where these words come from. We can't say the right of the right or the left of the right. Not only would that be confusing, it would mean something different on the other side, because this area on the outside would be the left of my left, the right of my right, the left of my left, but it's the same structure on both sides, right? So that's actually why we have the terms lateral and medial. It's a mirror concept. If I was on the side of a mirror and I could imagine the mirror was splitting me like a sagittal plane would split, and I do this, the exact same motion would happen on my left. And if I do this, this motion would happen on my left. Not this, unless my mirror is possessed. It has to be kind of the opposite, right? So that's what lateral and medial mean. It's the side of a side. And because our appendages are mirrored together, outside is lateral for both, and medial is kind of inside for both. Think of it like this. I'm going to use this analogy several times. The double doors, globally, from the room's perspective, spin in different directions. True? But yet, the name of their motion is the same. Open. I'm going to open the double doors. I'm going to close the double doors, because it's a mirrored concept. So here's my double door analogy. Same motion. same motion, even though your instinct wants to say, why wouldn't this be the same motion? Because they're doing the same thing globally. And it's like, yes, you're right, but joint motions aren't globally referenced. So we just have to watch out for those illusions. We're going to have these mirror effects happening all over the body that might look like they're different movements, but they're the same from the joint's perspective. Okay? Anybody else? Sir, you want to come talk? All right. Come on in if you want. He's swapping out the words. You look very scared. I think I startled you. All right. Let's see make sure I've got everything in here. Okay, so when we are going to communicate movement to our peers, to ourselves, more importantly to me, and me to you, we need to funnel down our, almost like a process. We're going to identify the side that we're talking about. Now remember, we're just going to have conversations about appendicular joints right now. Eventually we're going to get to this stuff. This is all about things you have two of, appendages. We need to identify the side. The side is the first thing we need to identify. Because it's almost kind of like if you don't get the side right, it doesn't even matter if you get the joint and the motion right. You're talking about something happening over here when really what's happening is over there. Amputate right leg. Use that a lot. Identify the side. And sometimes it's going to be easy, but sometimes people may be in some weird, twisty positions, and it may not be as easy to identify the right wrist from the left wrist, or the right ankle from the left ankle, or the right subtalar from the left subtalar, okay? So the first thing we want to do is make sure we identify the side that we are analyzing. And if we're analyzing someone in a picture or in class or ourselves, it's our perspective. It's our right, it's our left, it's our right femur, it's our left femur, it's our right knee, it's our left knee. Okay? Identify the side. Next thing you need to do is identify the joint that you want to talk about or that we want to analyze. That's the only way to make this make sense. Because in the Matrix, right, Neo's like doing all this. If you try to describe human movement all at once, then it really gets hazy. Now, I'm not saying discussing movement to a player, a family member, but in terms of us being able to see where a problem is, for us to be able to see maybe the issue isn't your hip, maybe the issue is in your foot. That's what's going to level you up to be able to understand that the problem at your shoulder is because of lack of mobility in your toe or something like that. Okay? And identify the side. Identify the joint that we're going to analyze, its position and its motion. And then once you funnel it down to there, the joints can only do so many things. So it's almost kind of like I'm giving you a safety blanket to, just like if you had a multiple choice test and you tried to eliminate answers, like that's kind of what this is. You should be able to identify a side, a right from a left. You should be able to identify a joint, shoulder, elbow, wrist, ankle, subtalar, knee, hip. And that puts you in a position to say, well, I know the only things the ankles can do is this and that. Or I know the only things the subtalar can do is that or this. And I know the only thing the knee can do is this or that. So at least it gives you a boxer's chance to narrow it down to analyze where you're at and or where you're going. Okay? Side, joint, motion, or position. So I'll put this little skeleton in here for us to practice. Right or left knee? Left. Right or left hip? Right. Right or left ankle? Okay. Now, if the skeleton was, and again, guys, this is some of you, I'm not saying all of you, but I was the same way. Like, I want to pattern recognize. I want to hear things that say, oh, okay, I got it. It's always going to be there. But what if I'd have showed the skeleton, like, looking this way, and I'd have said, which knee? That'd have been the left knee. So it's not about, when it's on the screen, this will always be left. It's part of the issue with me trying to retrain our brains not to just salivate memorized concepts. That's why I keep saying things like, do not assume, do not assume. Now, do not assume doesn't mean don't overthink. Try not to. It's just we have to look at the whole picture before we say something even as simple as right or left. Okay? Just make sure. Right. So we're going to develop a little bit of illusion stuff. So I think I used this in class, but I love this analogy. So when we were playing ball, coach would talk to us about our release points, our release angles, and he would use terms like, side arm throwing to the side, submarine were like these guys, that would be good. And then he would use terms like throw more overhead. And I remember thinking at one point, I was like, man, what if he wants me to do, I was a kid, what if he wants me to like pitch overhead? What if he wants me to like throw like is this overhead? Like, I don't know, he wants me to throw overhead. So like I'm thinking like my shoulder needs to be here. And I'm not knocking the coach. That's how they know how to communicate, is by global references. All right? But the reality is all the pitchers are throwing the same, because with basic physics, the further I get something away, the faster it could potentially go. Like a sling, you want to release it far away so that it can go fast. So I want to release it far away from my body, but if I'm trying to throw more overhead, like perpendicular to the ground, I have to literally reposition my body so that I can get it overhead. Like you'll see pitchers, like they're like leaning way over here on their release. Okay? So that's kind of an illusion, an example of global references. And then I use this one as a practice. Don't answer it right away. Give it some thought. This is how we practice. Which hip is in anatomical position and which hip looks like it is not? I'm not asking you to identify emotion yet. We're just practicing looking at something and saying, I know what my instinct wants to say, but maybe that's a global grounding gravity reference, and I need to look at it locally from the joints reference. So repeat, the question is, which of my hips is in anatomical position? Would it be my right or my left? Left. Good. Does anybody have a question on why my left hip is in anatomical position? Let me see it. Okay. So the one that's not an anatomical would be my right hip. You know what this question is? This is the question, but it's the exact same concept as this that I've already given you. You've already done. Does that make sense? I'm just not quick and athletic like I used to be. I lie, I was never athletic. Here, it's the same thing as this. This one was still an anatomical, but this one was flexed. This is still an anatomical, whoa! And we're going to learn that this is abducted.
The left.
My right hip was abducted here, but it's not even about what the name is. We're going to get to that. It's just to see how, and I tried to have my little hand to show you how like my hip is straight relative to the socket. So like one way to look at it is if you tilted your left ear to your left shoulder, you would see a straight hip joint. Does that make sense? Went along for the ride. All right. Going into more details of why global references are tricky or mess with us is this concept of local and global reference angles. So global or absolute angles are angles we give relative to ground and gravity. And practically, I'll give you a practical example that if I'm trying to throw to a catcher, globally, I have to release the baseball somewhere roughly globally here so that the ball has a chance to get to the catcher over there. Meaning that if I keep the ball for too long, the ball's going to just go straight into the ground. So global angles are used all the time in our brains to kind of map things out, and our eyes want to stay level to process things. But for our joint motions, those are relative angles. That's why sometimes students have a tough time seeing why this is the same as this at the knee, because your brain is like, but wait, my lower leg was parallel with the ground, and now it's perpendicular with the ground. That's what your instinct wants to say. Your instinct wants to make it an absolute angle change. And what I'm trying to train you to see is that I'm at a right angle here, and I'm also at a right angle here. So my knee didn't change its relative angle. Make sense? So this is developing the reasons why these kind of concepts are confusing. How is that hip moving? The leg is straight. How did this hip move? The leg is straight. You want to keep it absolute. Remember the shoulder question on the test? A lot of people miss that one because of this. Because your brain wants to make it an absolute angle change from the ground. And it's relative angle changes of the joints. Here is here's a different way to look at it, and then I'm going to stop kicking the horse. But I think this is an important way to look at it. Okay, if I had a board game, somebody name me a board game. Chutes and Ladders. What a good one. Chutes and Ladders. I'll roll it. It's a dice, right? I haven't played with my boys in a while because they always cheat. They always cheat. I'll roll the dice, and I'm supposed to go forward 4 spaces. Okay? We have been trained since we were children that the only movement I'm going to see is 1, 2, 3, 4. But in the human body, I roll a 4, and I can go forward like this. I can go forward like this. 1, 2, 3, 4. Does that make any bit of sense? I'm going to do it again. This is why your brains are messing with you. I roll a 5. Ken goes to your left. 1, 2, 3, 4, 5, and we give that motion a name, forward. But in the human body, I roll a 5. Ken can go forward 5 spaces by the board going back or to your left. More practically speaking, I can run, let's pretend this is west. I can run west, movable me, about a fixed room, or I can run west on a treadmill where I'm not moving at all, but the floor is actually moving east. But I'm still running in that direction. Is that better? We just never think of these kind of things, but we have to, because that's what's going to mess with us. When we get into examples like left hip external is the same as left hip external. And your brain is like, there's no way something that spins this way can be the same as something that spins that way. And I just showed you through examples that if we define clockwise as going from 6 to 7, fair enough? We have to accept that clockwise would also be the clock rotating counterclockwise, but it got me from 6 to 7. I'm going to do it one more time. This to that will be the exact same motion as this to that, because it gets me to the same place. If I travel north to Opelousas, I travel north. But if through an act of a higher being, if I stayed still and Opelousas came to me, I'd still be traveling north, because I'm north of where I started. I travel, it travels. I'm in the same place. Cool? I feel like it's Friday, but like it's Sunday because I'm preaching. I'm getting all preachy. And the Lord said, watch for illusions. I watch Coming to America. All right, so here are the most common illusions. Because guys, let's be honest, man, we don't need to spend a ton of time developing the easy ones. I'm assuming you've already had the easy ones. And the easy ones are, it looks like it's moving that way, and it is. You know what's even easier than that? It looks like it's not moving, and it's not. These are the ones we need to develop. Okay? It looks like it's moving, but it's not. That would be her right hip in this example. Like if she went to that position from anatomical, the leg is moving. I didn't say the hip. The leg is moving, and from an absolute angle, it looks like it moved 90 degrees from the ground, and it did. But that doesn't mean the hip did it. For those of you that have come into my office during my office hours to go via test, laugh at my Ken Dow band, but he's pretty practical. Watch this. Ken Dow's right hip is straight. Ken Dow's right hip is still straight, because Ken Dow's right hip is still straight. Ken Dow's right hip is straight. Ken Dow's right hip is still straight, because Ken Dow's right hip is still straight. It looked like it was extending, but it wasn't. Is everybody okay with that? The other type of illusion is, it looks like it's not moving, but it is. When you guys exercise and you do like, and forgive my, I was I didn't work out legs very much. Anybody else have Osgood-Schlatters disease, like knee pain? So an exercise like a good morning, right, where you have flexion and then you have extension, and you're using your glutes and your hamstrings. And biomechanics, we're going to go over the specific names of it. But what if you did that exercise on one leg? You know what leg wouldn't lower you down and bring you up? The leg that's in the air. I mean, it can't hold on to anything. It's the leg that's on the ground. It's those muscles. You can feel that, right? It's these muscles. Hey, dude, bring me back up. Hey, dude, lower me down. So wouldn't it make sense if it's that leg's muscles, wouldn't those muscles be affecting that leg's motion? Totally logical. That leg's muscles is going to affect that leg's motion. Letting you flex, and when it's time, making you extend. We have some shoulder illusions here. What if, I mean, this would never happen in an exercise, but what if she did, or I did, let me see if I can do this. I think I can. You can do it, Brian. We did the exact same illusion just with the shoulders. One shoulder looked like it was moving, but it wasn't. And the other shoulder looked like it wasn't moving, but it was. We identify side, joint, and then motion. So for my shoulders, my right shoulder did what? Nothing. My right shoulder didn't move. My left shoulder did what? Left shoulder flexion. Again. Flexion, flexion. Same thing. Same thing. Okay. Let's look at a couple other illusions. Did this one after class the other day. When some of you guys are going to be doing range of motion stuff as athletic trainers, as therapists, and the person that you're doing the range of motion or checking their assessment, they don't, and it's not their job to understand. If you say, I'm going to, let's say somebody's laying down on the table on their tummy, and you're going to check their range of motion, right? You're going to take their foot, and you're going to do this. That person only says, they're trying to bring my foot down to the table. It's a global reference. And if I run out of real estate, they're going to find other ways to move to get their foot closer to the table. You're going to cheat. It's not their fault. They don't know they're cheating. They're just trying to accomplish what they feel you want them to do. If you've ever worked out with a friend and, you know, they're like, sometimes it's obvious, but sometimes they don't even realize they're compensating. Sometimes they don't even realize they're getting some extra help from other places because they're just trying to move the weights. It's kind of the same thing. So what will happen is you'll start to rotate the hip, and then when you get to end of a range of motion, they'll literally start rotating their whole pelvis to keep going. They may not see it. Everybody else in that room may not see it. My students need to see it. And when you go to grad school, you are going to help other students from other universities down the street see it.
So, whenever you're saying that, like,
I didn't say which street.
well, if you're checking the
Legal stuff.
Whenever you're saying, like, if you're checking capability, you would want the knee to stay in a fixed position and just not move completely, so that when you're checking side to side, you're just checking the hip.
For this, and we're not going to get this on this first part. What you would want to do as a clinician is you want to make sure you keep their opposite side of the pelvis down while you internally rotate, because if you don't, when you let up, their whole pelvis is going to spin. Or think of it like this. In class, when we do shoulder, I'm going to ask you guys to try to rotate your shoulder back, like some pictures that I'm going to show you, like clockwork, students are like, I can get my hand back there, and then they like, because in your mind, it's just get hand back. It doesn't matter how. But if I'm trying to check your shoulder rotation, it matters how. I need to stabilize and make sure you don't cheat. And I'm going to put your baseball guy. Stand up real quick. You don't have any shoulder problems, huh? So, not much. So what I would do is, I'd be here, try to minimize your scapula, and then go here. But if I don't, then your instinct is to go back with it. So it's about trying to stabilize with stabilization. It's trying to prevent compensation so that we can check the rotation of where we want to. All right. Now, this class isn't about range of motion assessment, but I'm trying to prove points to how your body says hand go back, arm go up, foot go back, we have 20 plus, in my case, 40 plus years of life data that's globally referenced, that's absolute angling referenced. And we need to look past that and look at the local references. Okay? And then this is my favorite one. You may not be able to see it, but most people would say that this person's shoulder is abducted 90 degrees. In other words, 90 degrees from his side. But he's actually abducted more than 90 degrees. Can you see it? Because that 90 degrees is a global reference. But he's tilted his whole body over. So in other words, if you go left ear, left shoulder, and look at his trunk from a leaning position, his 90 degrees technically would be here for his shoulder. Does that make sense? He's past 90 degrees. That's the whole point of leaning, and so that you can actually get more range of motion while being more perpendicular to gravity. But just because his arm is level with the floor doesn't mean his shoulder is at 90 degrees. Make sense? Any questions so far? Okay, let's get into the ankle joint. The first thing I'm going to teach you is when you have bony articulations or joints, it's Brian, think of an analogy. A car is an unbelievably useful tool for movement, and it can be dangerous. Movement can be dangerous. So we have safety things in place in cars, seat belts, airbags, crumple zones. We want to allow movement because movement is useful, movement is life, but we also want to protect potentially too much movement, because too much movement might cause sprains, dislocations, and bad things. So when we articulate these bones to form joints, we kind of have a natural trade-off. You're going to hear me say this a lot. What we gain in stability of a joint, we're going to have to give up in mobility of the joint. And what we gain in mobility of a joint, we're going to have to trade off the stability of a joint. You can't be both. You can't be excessively movable. Think of it like this. The more you drive, the more chance you might get in a wreck. Odds. So if a joint never moves, it can never move too much. You can never get hurt. Okay? So your ankle joint proper, or the ankle joint itself, is here. We call it, in fancy terms, a talocrural joint. It's where the talus, which is a dorsal bone, articulates nice and snug inside of what we call an ankle mortise, formed by the tibia and the fibula, the distal tibia and fibula. Which one is mostly weight bearing? The tibia or the fibula? The tibia. But the fibula also about 10 or 15% of weight bearing as well. So it's not just the tibia. It carries most of the load, but the fibula also weight bears as well. This is a hinge joint, guys, a uniaxial hinge joint. All the ankle can do is rotate like a wheel. In fact, that's our wheels. Our ankle joint is literally our wheels that get our cars, our bikes, our motorcycles. That's how we roll. But unlike a wheel that can keep spinning, we have to spin, reset, spin, reset, and that's why we right, then left, then right. I guess unless you're a kangaroo. But they reset in the air. It would make sense that if these are our wheels to rotate us, to translate us, it would make sense we would want to protect this immensely. There's a lot of protection here. Not only from the socket or the mortise, but the way the talus sits in there, guys, it only is allowed to do this. There's no room to do this, and there's no room to do that. In fact, this looks like it would hurt a lot. And this looks like it would hurt a lot. The ankle joint are our wheels, and we need to protect those wheels. Who's heard of a high ankle sprain? There's nothing high about it. That's an ankle sprain. That is literally a sprain to the ligaments that form this joint. The wheel joint. And the reason it takes so long to heal is because every time you weight bear, you're bowing out those chicken wing bones. And as you know, like in order for something to heal up, you kind of have to not piss it off. Takes a long time. A low ankle sprain is not the ankle. And that's what today's lesson is about. Before we get into the specific joint motions, man, I have to etch into your brain that underneath the talus, underneath the water, submarine, submariner, subtalar, you have these gliding dorsal bones, these shifting and gliding dorsal bones, the subtalar and transverse, the across dorsal bones that shift and glide and move. When you're on a skateboard, the wheel helps you go forward and back. But what does the wobble help you do? Balance. Yeah. So when you're balancing and you notice this sway from side to side, that's underneath the talus, all those dorsal bones kind of gliding and shifting. So when you have a low ankle sprain, that's not your ankle joint. That's your subtalar and transverse dorsal joints, which should make a lot of sense. Because if you've ever sprained your ankle, it doesn't hurt you to run straight, depending on if it's a minor sprain. It doesn't hurt you to run straight. You know why? Because your wheels are still fine. What does it hurt you to do? Do things that involve this kind of motion. The sway stuff hurts, the side to side. But if you have a mild ankle sprain, coach, I can run straight. Well, if it's a different joint, why do we call it ankle? We don't know any better. At least you need to know better. But, you know, it's not like my dad, oh, yeah, I sprained my ankle. It's not, well, father, actually, that's your subtalar and transverse dorsal. But we need to know. We need to know that this is in a different place than this. Now, they live in the same apartment complex. Your joints have these things called capsules. They're just like water balloons. But the water balloon isn't cheap in plastic. It's ligamentous tissue. In fact, that water balloon is all ligament. And the ligaments we know, like the MCL, LCL, anterior talar fibula, all that is thickened parts of the water balloon that is the capsule. It's thickened areas to prevent common stresses that are trying to move that joint in places we don't like them. That's all a ligament is, a thickened area. Think of it like this. Condyles and epicondyles and tuberosities are thickened parts of bone where muscles are yanking. Why wouldn't you have thickened parts of ligaments that are trying to protect a little extra from abnormal movement? So the final lesson for today, we're going to get into specific motions on Monday. The ankle is a uniaxial hinge joint, and it lives at the top of the apartment complex, and underneath it lives the subtalar and transverse dorsal joints. They live in the same building, but they don't live in the same apartment. Cool? All right, guys, y'all have a good weekend.